In all the initial simplex table, all the Zj value will come 0. For maximization problem, all Cj minus Zj value should be negative or 0. So first volt value is 3, corresponding key column is 1, corresponding key row is 2. Hello everyone, welcome back to my new session on operation research. So in my last session, I have discussed about linear programming by graphical method. I have explained all types of graphical method. Please practice the problems, easily you can score in graphical method. So today I will discuss the next topic called simplex method. So in graphical method, easily you can solve using two variables. If you get any three variables, so how do you solve in graphical method? It's impossible to solve in graphical method. If it is two variables, easily we can solve in graphical method. If it is three variables, easily we can solve using simplex method. Let's get started now. We have different methods for solving LPP. Already have discussed graphical method. So after graphical method, we can use simplex method, big M method and two-phase method. So if you have any three or more than three variables, so easily we can solve using simplex method, big M method and two-phase method. So let's see what is the meaning of this simplex method. The simplex method will be especially useful because the graphical method can be used only when there are not more than two variables. So in graphical method, we can solve using only for two variables. If we get more than two variables, we can solve LPP by simplex method. And the simplex method provides a systematic algorithm which consists of moving from basic feasible solution to another in a progressive manner. Simplex method is a standard technique in linear programming for solving optimization problem. So if you have any three variables, we can go for simplex method. So in simplex method, the value of objective function is continuously improved. Simplex method is a systematic technique in linear programming for solving an optimization problem. By adding a slack variable, we can convert all inequalities into equalities. So we can easily find the optimization problem in simplex method. And for finding the optimization problem, we have to use some steps. Let us understand with an example. So objective function or the Z equation should always be maximization type. So in simplex method, all the objective function, that means Z equation should be maximization type. So if you get any minimization type, you need to convert this into maximization by multiplying -1 to the equation. So all the objective function type should be maximization. So if you get minimization, you need to convert this into maximization by multiplying -1. And all the constraints should be converted into equations logically by applying some mathematical techniques. So second step is all the constraints should be converted into equation form. So all the constraints. So what is the example for constraints? So x plus 5y less than or equal to 7. So this is one constraint. So this type of constraint should be converted into equations logically by adding mathematical techniques. So how we can convert this into equation form? So x plus 5y is equal to 7. So this is one equation. So all the constraints should be converted into equation format, and also we can add the slack variables S1, S2, S3, etc. So all the constraints should converted into equations. So x plus 5y plus S1 is equal to 7. So now it is in the form of equation. So I have converted this constraint into equation format by adding this mathematical technique. And the RHS of all inequalities should be non-negative. Example, minus x plus 3y minus 5z less than or equal to 8. So, third rule is all the inequalities. Now, this is in the form of inequalities. So, you need to convert this into equations. So, before that, all the RHS should be non-negative. That means all the RHS values should be positive. If you get any negative, you need to convert this into positive by multiplying minus 1. You need to convert this into positive. All the RHS values should be non-negative. And the next step is all variables must have non-negative values. So, all variables and all the constraints should be less than or equal to sign to solve by simplex method. And all the constraint, example 2x minus 3y plus 4z less than or equal to 18. So, now this is one constraint. All the constraints should be less than or equal to sign. Less than or equal to sign, then we can solve this by simplex method. So, if you get any greater than or equal to 18, then we can convert this into less than or equal to by multiplying minus 1. These are the steps we have to use in simplex method. It is very simple concept. It is mathematical technique. So, all the objective functions should be maximization type and all the constraints should be converted into equations logically by adding mathematical techniques, and all the RHS values should be positive and all the variables must have non-negative values and all the constraints should be less than or equal to type. If your objective function and constraints are not applying these rules, you have to convert that into simplex rules. For solving the simplex method, you have to use these steps. Then we can easily solve using simplex method. So, let's get started now. Here, I have an objective function. Max z is equal to 2x plus 4y. So, what is the first rule? All the objective function should be maximization type. So, now this is in a form of maximization type. Then, subject to constraints. You just observe these constraints. All the RHS of this constraint should be positive. Is this in a positive way? Yes, it is in positive. Then we can proceed. Then what is the next step? So, all the constraints should be converted into equation format. So, this is not in a equation format, it is inequality constraints. Then I will convert it into equality by adding slack variables. So, this is not in a equation format. So, I will convert this constraints into standard form by adding slack variable. So, this is the first step. So, first you just convert this into standard form. So, you have two constraints 3x plus y plus s1 is equal to 22. So, first constraint is 3x plus y less than or equal to 22, less than or equal to greater than or equal to means it is in a inequality format. So, first step is you need to convert this constraint into standard form. Standard form in the sense convert this inequalities into equation method. So, equation means 3x plus y plus s1. S1 means it is a slack variable. So, what is the slack variable? Slack variable is represented by s. So, what is the meaning of this slack variable? Slack variable is a variable, all the inequalities is converted into equalities by adding S1, S2, S3, etc. So, all the inequalities is converted into equalities, that is called as slack variables. By adding the slack variables S1, we can convert this inequality into equation format. So, this is equation number 1. And second constraint is 2x plus 3y less than or equal to 24. By adding the second slack variable, we can convert this into equation. For equation 1, I have added S1 slack variable, and for equation 2, I will add S2 is a slack variable. So, 2x plus 3y plus S2 is equal to 24. Now, this is one equation. So, first equation, equation 2. I will repeat. So, first step is you need to convert this constraint inequalities into standard form, that means equation form. So this is RHS value. RHS value should be positive. So here we have positive value only. So you need to convert this into equation format by adding the slack variables. All the inequalities is converted into equalities. I have converted this into equalities. So by adding the slack variable, I have converted this inequality into equality. I have added two slack variables because I have two decision variables here. Have two decision variables x and y. So here I have only two constraints, so I have added only two slack variables. If you have three constraints, so you can add one more slack variable, so S1, S2, S3, S4, etc. So how many constraints are there? That many slack variable you can add. So all the inequalities you have to convert it into equalities. And here I have added two slack variables, and also I will convert this objective function into standard form. So I'll write max z is equal to 2x plus 4y. So how many slack variables have added? Two slack variables, that is 0s1 plus 0s2. So now this is in a standard form. So first step is you have to convert this objective function by adding the slack variable with 0 coefficient. For objective function, all the slack variable coefficient should be 0 and 0 only. So here I have only two slack variables S1 and S2. So I have added two slack variables with 0 coefficient, 0s1 plus 0s2. So if you have three slack variables here, so you can add one more 0s3. So like this you can convert this into standard form. So first thing is you just see the constraints. So all the RHS should be positive and all the inequalities you have to convert it into equalities by adding the slack variable S1 and S2. So after that I will convert this objective function into standard form by adding the slack variable S1 and S2 with 0 coefficient, 0s1 and 0s2. Now this is in a standard form. Standard form. So this is your first step in your simplex method. After converted this into standard form, you can proceed for initial simplex table, and after this standard form you can proceed for initial simplex table. So first step is all the objective functions and constraints should be in standard format. So now it is in a standard form, then I can proceed for initial simplex table. So first is initial simplex table. So this is initial simplex table. How to find this initial simplex table? So this is a basic table in simplex method. So here you just observe this table. Here in table I have written Cj, that means coefficient of objective function. Cj stands for coefficient of objective function. Coefficient of objective function. Coefficient of objective function, and BV stands for basic variable. Basic variable. And CBO stands for coefficient of basic variable. Coefficient of basic variable. So first I will write the coefficient of objective function. So coefficient of objective function means you just see the standard form only. Just observe this standard form. This is my objective function. Coefficient of objective function in the sense, so what is the coefficient of x here? It is 2. And what is the coefficient of y here? It is 4. And what is the coefficient of S1? 0. Coefficient of S2 is 0. So this is your first step. So first you have to write the coefficient of objective function in standard form. You just see the standard form of objective function. Just write the coefficient of objective function. So 2 is the coefficient of x and 4 is the coefficient of y and 0 is the coefficient of S1, 0 is the coefficient of S2. You just write the coefficient of objective function first. So next is basic variable. So how many basic variables are there? X, y, S1, S2. These are the basic variables. So x, y, S1 and S2. So these are the basic variables. And you just see the question now. In question we don't have S1 and S2. By converting this inequality into equality, I have added two slack variables called as S1 and S2. That is the main basic variable here. So in below I'll write S1 and S2. So this is common for every problem. So this is one common table for every problem. So first is coefficient of objective function, basic variables. We have x, y, S1 and S2, and basic variables which have taken, that is S1 and S2 is a slack variables, that is by basic variable also. And now have to write the coefficient of basic variable here. So what is the coefficient of basic variable here? It is 0. Coefficient of basic variable S2 is 0. So coefficient of basic variable S1 is 0. Coefficient of basic variable S2 is also 0. So this is a basic step. Now after this you have to write, and after this in this place you have to write the coefficient of x, y, S1, S2 in equation number 1, and here you have to write the coefficient of x, y, S1, S2 in equation number 2. Listen carefully. So here I will write the coefficient of x in equation number 3. Here I will write the coefficient of x in equation number 1. So coefficient of x in equation number 1 is, it is 3. And coefficient of y in equation number 1 is, again it is 1. And coefficient of S1 in equation number 1 is 1. And coefficient of S2 is not there. So I will write it is 0. And coefficient of x in equation number 2 is 2. Coefficient of y is 3. And coefficient of S1 is not there. It is 0. And coefficient of S2 is 1. So this is the next step. So here in this place you have to write the coefficient of x, y, S1, S2 in both the equations. Equation number 1 coefficients and equation number 2 coefficients. And after that you have two more steps called solution and ratio. You have to find the solution and ratio. You just see the equation number 1 and 2. In equation number 1, in place of RHS, we have one solution called 22. So this is your solution value. In equation number 2, you have RHS value called 24. This is equation number 1 solution and this is equation number 2 solution. So in place of solution, you have to write the RHS value in both the equations. So this is for equation number 1 and this is for equation number 2. And after this, you have to find the ratio and you have to find the Zj value and Cj minus Zj value. This is your initial table. So whatever I have written here, that is your given value. First you have to write the coefficient of objective function and basic variables, and coefficient of basic variables is S1, S2, coefficient is 0 and 0, common for every problem. And here you have to write the coefficient of x, y and S1, S2 for equation number 1 and for equation number 2. And this is solution in both the equations, that means RHS of the value in first equation and RHS of the value in second equation. So this is your given values have written in the initial table. And what is the next step? So here you have to find Zj and Cj minus Zj. So how to find Zj value? For finding Zj value, we have one equation, that is Zj is equal to sigma I is equal to 1 to 2, that is coefficient of basic variable and Aij. That means row and column. So here, how to find the Zj value? 0 into 3 plus 0 into 2. I'll repeat how to find the Zj value. 0 into 3 plus 0 into 2, it is 0 plus 0 is 0. And again 0 into 1 plus 0 into 3 is 0 only. And 0 into 1, 0 into 0 is 0. And again 0 into 0 plus 0 into 1 is 0. Listen carefully, in all the initial simplex table, all the Zj value will come 0 only in initial simplex table. In initial simplex table, all the Zj value will come 0 only. And after moving to the iteration 1, iteration 2, Zj value will be changing. But in initial simplex table, all the Zj value is 0, 0, 0, 0. And what is the formula for finding Zj? 0 into 3 plus 0 into 2, 0 into 1 plus 0 into 3, 0 into 1 plus 0 into 0, 0 into 0 plus 0 into 1. So, all the values is 0 only. And in iteration 1, again you need to use the same method for finding Zj value, but in next iterations you will get some other values. So, but in initial simplex table, Zj value is always 0 only. And after finding the Zj value, you have to find Cj minus Zj. What is Cj minus Zj? Here, Cj, this is Cj value, and subtract this Cj value from Zj value. So, 2 minus 0 is 2. 4 minus 0 is 4. 0 minus 0, 0. 0 minus 0 is 0. So, now we got the value of Cj minus Zj. So, this is a method for finding Cj minus Zj and Zj value. After finding this Cj minus Zj, you have to find optimality condition is satisfied or not. So, how to check whether it is satisfied or not? So, listen carefully. For maximization problem, all Cj minus Zj should be less than or equal to 0. So, less than or equal to 0 means it is negative value. All the values should be negative or it should be 0. Keep in mind, for maximization problem, all Cj minus Zj values should be negative or 0. Till that you need to continue the iterations. So, after this initial simplex table, in first iteration, second iteration and third iteration, you will get the final answer. But for maximization problem, all the Cj minus Zj value should be negative or 0. And for minimization problem, all Cj minus Zj value should be greater than or equal to 0. That means all the values should be positive or 0. It is very important concept. Please keep in mind, this is maximization problem. So, all the Cj minus Zj value should be negative or 0. But here I have positive value, positive value. So, you have to convert this into negative value. Till that you need to continue the iterations. So, this value is not satisfying optimality condition. So, this is not satisfying optimality. If it is not satisfying optimality condition, you have to proceed the next iteration. Here, after getting the Cj minus Zj value, you can find out that this is not satisfying optimality condition. If it is not satisfying, you can proceed the next iteration called iteration 1. So, after this initial simplex table, we can move to the iteration 1. So, after finding this Zj value and Cj minus Zj value, and if it is not satisfied optimality condition, you have to find the key column and key row and pivot element. Key column, key element, key row. You have to find key row, key column and pivot element or key element. So, how to find the key column, key row and pivot element? So after this, you have to see the Cj minus Zj values. So here, the maximum value you need to mark. You just observe this Cj minus Zj value. Here we have plus 2, plus 4, 0 and 0. In Cj minus Zj value, for getting the key column, we have to find the maximum value out of this Cj minus Zj. The maximum positive value for maximization problem, you have to find the maximum positive value. So which is a maximum value here? The maximum value is 4. So here the maximum value is 4. So this 4 comes under column Y. So I will mark this is my key column. Listen carefully. After finding the Cj minus Zj, you have to find whether it is condition is satisfied or not. Optimality is not satisfied, you can go for the next iteration. So before that, you need to find the key column, key row and key element. So how to find the key column? So for finding the key column, you just see the Cj minus Zj value. So you just select the topmost, that means maximum positive value. So which is the maximum value here? 4 is my maximum value. So I will select this as a key column. This 4 comes under column Y. I will mark it as key column. After finding this key column, we have to find the ratio. How to find the ratio value? So for finding the ratio value, we have formula called solution divided by key column. So solution value is 22 and key column is 1. So 22 divided by 1 is 22. And again solution divided by key column is equal to 24 divided by 3. First ratio is 22 divided by key column and 24 divided by key column. So 24 by 3 is equal to 8. So here we have 22 and 8 in a ratio column. We got two ratios, that is 22 and 8. So here after finding the key column, we have to find the key row. So how to find the key row? For finding the key row, you just observe the ratio column. For finding the key row, you just observe this ratio column, you will get the key row value. How to select this key row? Here in ratio, you have to select the minimum positive value. You have to select the minimum positive value. So here we have 22 and 8. The minimum positive value is 8. So I will select this as a key row. So this 8 comes under the row called S2. This is my key row. So I will mark 8 is my minimum value and it comes under S2 row. So this is my key row. Here I got key column. So this is my maximum value in Cj minus Zj. So here you have to find the maximum positive value. Maximum positive value is 4. So this maximum value comes under the column called, this is key column. This is my key column. So after getting this key column, you can find the ratio value by using this formula, solution divided by key column and solution divided by key column. So you got two values, 22 and 8. Out of these two values, the minimum value is minimum positive value. Minimum positive value is 8. It comes under the row called S2. So this is my key row. This is key column and this is key row. Including solution, you have to mark the key row. And after this key row and key column, you have to find the pivot element. Pivot element or key element. So pivot element or key element. How to find the pivot element? So you just observe this. Here I got key column and key row also. So here 3 is my key element. How it is 3? 3 is common for both key column and key row. Then I will consider as this is my key element. 3 is common for both key column and key row, then I can consider this is my pivot element. So 3 is my pivot element or key element. So pivot element or key element is equal to 3. You just see the common value for both key column and key row, you will get the key element. Here we got the key column, key row and key element also. So after finding this key column, key row and key element, we have to find the entering variable and leaving variable. So how to find this entering variable and leaving variable? You just observe this key column. This key column comes under the maximum value 4. So for maximum value, you will get the key column. So this key column comes under the variable called y. This key column comes under the variable called y. So y is my entering variable. Y is equal to entering variable. So key column comes under the variable called y. So this is my entering variable. And key row comes under the variable called S2. This is my leaving variable. This is entering variable. This is leaving variable. Incoming variable, outgoing variable. So leaving variable comes under the key row and entering variable comes under the key column. So this is your main concept, entering variable and leaving variable. So here in place of leaving variable, I have S2. You have to replace this S2 by y. This is entering variable, this is leaving variable. So in place of leaving variable, I can write my entering variable y. So you have to replace this by y because y is my entering variable. So you can replace this by y. So in next iteration, in place of S2, I will write y. So what is the coefficient of y? So coefficient of y is 4. In next iteration, I will write the coefficient of y and I will write the incoming variable. I will delete this leaving variable. So this is your simplex method concept. Listen carefully. So this is your initial simplex table. So in initial simplex table, you have to find the entering variable and leaving variable. This entering variable and leaving variable is very important for proceeding the further table. So this is your initial simplex table. Still you have to find the iterations. So in initial simplex table, you know the value of key element, right? Key element is 3 and entering variable is y and the leaving variable is S2. Leaving variable is S2. So leaving variable is S2. You have to replace this S2 by y. And key element is 3. So here in initial simplex table, you just observe this. This is my key row and this is non-key row. This is key row and this is non-key row. And this is key column and these are the non-key columns. So first you have to observe the key rows and non-key rows. This is very important for finding the iterations. This is key row and this is non-key rows. And next we will find the first iteration, that is iteration 1. In first iteration, so what is the first step? Again you have to find the coefficient of objective function, that is 2, 4, 0 and 0. 0, 0 means S1 and S2. And basic variables x, y, S1 and S2. So this is solution and again it is ratio. So here the basic variables, you just observe this basic variables. S1 is there and S2 is there. Already I have told you that this is my leaving variable. So leaving variable means S2 is replaced by y because this is entering variable. So I will write in place of S2, I will write y and 4. So this is 0 S1 and 4 is my coefficient of y. This is entering variable, and living variable is S2. Have deleted the living variable. So, in place of living variable, have written the entering variable. In next step, you have to replace this old values. You have to find the new values. So, this is key row and this is non-key row. So, first you have to find the key row. So, here what is the key element? Pivot element is 3, key element is 3. Using key element, we can find the key row values. First, list all the key row values: 2, 3, 0, 1, 24. 2, 3, 0, 1 and 24. List all the key row. So, this is my key row. So, these are the old key row values. So, using that old key row, I will find the new values. So, what is the formula for finding key row? Key row means old value divided by key element. This is old value. So, formula for finding the key row is old value divided by key element or pivot element. So, key element is 3. Old value is 2. Key element is 3. So, 2 by 3. And old value is 3. Key element is 3. 3 divided by 3 is 1. And old value is 0. Key element is 3. So, 0 by 3 is 0. And old value is 1. Key element is 3. It is 1 by 3. Old value is 24. Key element is 3. It is 8. So, now write all the new values in place of old key row. So, first value is 2 by 3 and second value 1, third value 0, fourth value 1 by 3 and next value is 8. So, this is your new value. Using old value in first initial simplex table, we can find the new value in iteration 1. And also we have non-key row. This is called as key row and these are the non-key rows. So, next write all the non-key rows, list all the non-key rows. So, here 3, 1, 1, 0, 22. 3, 1, 1, 0, 22. So, these are non-key rows. Non-key rows. Here using non-key rows, we can find the new value by using the formula. So, what is the formula for finding the non-key rows? Old value minus corresponding key column into corresponding key row divided by key element. So, this is your formula for finding the non-key rows. For finding the non-key rows, you have one formula: old value minus corresponding key column into corresponding key row divided by key element. So, this is key column and this is key row. Corresponding key column into corresponding key row divided by key element. I have listed all the non-key row values. So, first value is 3. You just listen this. So, first non-key row is 3. Here you just substitute this value to the equation. This is old value. Old value is equal to 3 and minus corresponding key column. So, here key column is 1 and 3. To this number, which is the corresponding key column? For 3, corresponding key column is 1 and for 1, corresponding key column is 1. You are not supposed to consider this as a key column because it is added to the key row. So, this is old value minus corresponding key column is 1 and the corresponding key row is 2 for this number. I will repeat. For 3, corresponding key column is 1 into corresponding key row is 2. And for 1, corresponding key column is 1 and corresponding key row is 0. And for 0, corresponding key column is again 1 and corresponding key row is 1. This key column is common for all the non-key rows. Keep in mind, this key column is common for all the non-key rows. I'll repeat, old value is 3 minus corresponding key column is 1 into corresponding key row is 2 divided by key element, and old value is 1, corresponding key column also 1 into corresponding key row is 3, and old value is 1, corresponding key column is 1 and corresponding key row is 0, and old value is 0, corresponding key column is 1 and corresponding key row is 1, and old value is 22 and again corresponding key column is 1 and corresponding key row is 24. By using this formula, you can find the new values in the next iteration. So first old value is 3, corresponding key column is 1, corresponding key row is 2. So 3 minus 1 into 2 by 3. 3 minus 1 into 2 divided by key element is 3. So answer is 3 minus 2 by 3. 9 minus 2 by 3, take LCM, it is 7 by 3. So first value is 7 by 3. And next value is 1, old value is 1, corresponding key column also 1 and key row is 3. So 1 minus 1 into 3 by 3. 1 minus 1 into 3 by 3 is equal to 1 minus 3 get cancelled, 1 minus 1 is equal to 0. I will write 0 here. And the third old value is 1, old value is 1, corresponding key column is 1, corresponding key row is 0. So 1 minus 1 into 0 by 3. 1 minus 1 into 0 by 3. So 1 minus 0 is 0, 0 by 3 is 0, 1 minus 0 is equal to 1, and the next value is old value is 0 and the corresponding key column is 1 and the corresponding key row is 1. So 0 minus 1 into 1 by 3. 0 minus 1 into 1 by 3, it is minus 1 by 3. Minus 1 by 3, I will write here. And the next one is 22 is my old value. Old value minus corresponding key column is 1, corresponding key row is 24. So 22 minus 1 into 24 by 3. 22 minus 1 into 24 by 3. So 3 ones are 3 8s are. So 22 minus 8. 22 minus 8 is equal to 12. So I will write here 12 is my new value. So here I got all the new values. Again you can find the ZJ value. So what is ZJ? 0 into 7 by 3 plus 4 into 2 by 3. So 0 into any number is 0 only. So 4 into 2 by 3 is 8 by 3 and 4 into 1 is 4. 0 into any number is 0. So I will add only this number. 4 into 1 is 4. 4 into 0 is 0. 4 into 1 by 3 is 4 by 3 and 4 into 8 is 32. So this is your ZJ value, and find out CJ minus ZJ now. CJ minus ZJ, 2 minus 8 by 3. So 2 minus 8 by 3, take LCM, 6 minus 8 by 3 is equal to minus 2 by 3. Minus 2 by 3. And 4 minus 4, 0. 0 minus 0, 0. 0 minus 4 by 3, it is minus 4 by 3. Now you can find the optimality condition, whether it is satisfying the optimality condition or not. So already I have told you that for all maximization problem, Cj minus Zj should be less than or equal to 0 or negative value. You just observe this Cj minus Zj. So here I got negative value, 0 and 0. So this values satisfying the optimality condition. So now you can stop the iteration here because it's satisfying the optimality condition. Satisfied optimality condition. Satisfying optimality condition. So now the value of Zj is equal to 32. This is your maximum value. Max Z is equal to 32 and value of S1 is equal to 12 and value of Y is equal to 8. So here we don't have the value of X. So X value is not there here. We have S1 and Y. So Y value is equal to 8. S1 value is 12. We don't have X value. So X value is equal to 0. So max Z is equal to 32 and X is equal to 0. Y is equal to 8. Now you can cross verify this. You just substitute this value to the objective function. Max Z is equal to, objective function is 2x plus 4y. Max Z is equal to 32 and 2 into x. X value is 0 plus 4 into y value is 8. So 0 plus 4 into 8 is 32. So 32 is equal to 32. LHS is equal to RHS. Hence it is proved. So this is about your simplex method. It is very simple concept, but you need to use the mathematical technique for this. So easily you can score 8 marks in simplex method. Please practice this problem. Easily you can score 8 marks in simplex method. It is very important concept. Definitely there will be a problem on this concept. In my next session, I will discuss some more problems on simplex method. Thank you.